Welcome to solverfy.
So here we have the circuit, and these are the two voltage sources, in fact the three voltage sources, and we need to figure out the current flowing through each of these resistors involved in this connection. So let us take the tentative direction, and here I can, before that, combine these two EMF sources. So I just shift this EMF, and we can see the positive terminals are connected together. So the effective EMF here will be 6 volt, and this is 2 ohm resistor, and we have this connected with this 4 ohm resistor, and here we have 5 ohm and connected to this 36 volt battery. So we have obtained the 6 volt because positive terminals are connected. 20 minus 14, that will be 6 volt. So let us redraw the circuit even more clearly. So we have this 36 volt battery, and there is 5 ohm resistor here. Here also we have the 2 ohm resistor, and let's again shift the position to make it look symmetrical. So we have 6 volt battery like this. This is 6 volt, and these are connected, and they are connected across this 4 ohm resistor. So here, to find out the current that is flowing through each of these resistors, first this battery, so let us take the potentials at all these points. So it will be 0, and here the potential will be 36, and here the potential will be -6, and let us take the potential here to be V. So once we find out V, we can figure out the current that is flowing through all the resistors. So let's take any junction into consideration. So let's say I take this junction. So at this junction, let us take the directions of current. So this is the current, and here this is the current, and this is the current. So let's take this as I1, this is I2, and this is I3. So if we apply Kirchhoff's current law here, total current entering this junction is I1, and that should be equal to the total current that is leaving this junction. So we can figure out I1, I2, and I3 because we know the voltage across the terminals and the resistance. So we use Ohm's law here. Current will be obtained using change in potential by the resistance. So here the current is flowing like this. So this is at high voltage. So 36 minus V over 5 will be equal to I2. I2 here this is the high voltage because current moves from high voltage to low. So V minus -6 over 2 ohm plus this I3. So that will be V minus 0 by 4. So let us solve this to get V. So we get 36 minus V over 5 equals to V plus 6 by 2 plus V by 4. So that gives 36 minus V by 5 equals 2V plus 12 plus V by 4. So we simplify it further. We get 3V plus 12 by 4, and cross multiplying this gives us 36 times 4. 144 minus 4V equals to 15V plus 60. So here we get 19V equals to 84. And this gives us the value of V as 84 over 19. So this 84 over 19, if we simplify this, we get 4.4 volt approximately. So this gives V as 4.42 volts. So let's take this value of V, 4.42 volts, and that can give us the value of current. So what will be the current here that's flowing through this 2 ohm? That will be I2, and I2 was V plus 6 by 2. So V, we got it as 4.42 volt. So let's put here. So 4.42 plus 6 will be 10.42 by 2. So that will be 5.21 amperes. Similarly, current flowing through this 4 ohm will be I3, and that will be V by 4. So that will be 4.42 over 4. Simplifying this gives us 1.1 ampere approx. And I1 will be 36 minus V by 5. So 36 minus 4.4, let's take approximately. So that will be 31.6 by 5, and this will give us the value of I1 as 6.32 amperes. So these are the currents that is flowing through the resistors as indicated in this diagram.